Hi you guys. This video is to give you a little bit more clarity in terms of when you would want to apply IVT or MVT, knowing how and when to use it. So here we go. So this is what we did way back when. Here's a list of your theorems. You're more than welcome to email me if you want a PDF of all the theorems. But really, there's only 4 listed here, but 2 really that you need to know, okay? And that's going to be IVT and MVT here, okay? Rolle's theorem is really just a special case of the mean value theorem, so you really don't need to state Rolle's theorem specifically there, okay? So here we go. Intermediate value theorem was that birth height scenario. If you're born at 14 inches and now you're currently 6'5", then throughout your entire life, you would have hit every single inch in between. Okay? Intermediate, meaning all the middle values. Okay? So IVT will work as long as the function is continuous on a closed interval, then you could use the intermediate value theorem. And you're going to have this in front of you. You just have to know how to use it. Okay? Mean value theorem. There are actually 2 conditions, okay? The function has to be continuous on a closed interval and differentiable on an open interval. And if those 2 conditions are satisfied, then basically your secant line, the slope of that secant line, there exists a tangent line that's parallel to that one, meaning they share the same slope. Another way of saying that is that I rock will equal A rock, or that the derivative will equal the average rate of change, slope, okay? EVT, although not very popular, it did pop up, I think 2 years ago. I forgot which year, but I'll show you how to do that one as well, okay? But really, it's just these 2. So here's what we're going to do. I'm going to first show you what you should be looking for, and then we'll go from there, okay? So in these type of problems, okay, they're going to ask you for something and they're going to give you something, okay? So given something, and usually it's a table, okay, they're going to ask you, is it possible for something else to exist? Or explain why it's possible for this to exist, okay? But in short, and this might not make sense until later, but basically, if what they ask for is the same thing as what they give you, okay? So if what they're asking for is what they give you, you're going to use IVT. Now, if they're asking you for the derivative of what they give you, you're probably going to lean towards MVT. Okay? It'll make a lot more sense once I actually do some problems. So here we go. First, how do you know when to actually think about these 2 theorems? Okay, so we're just going to look at the phrasing real quick. And it's usually with a table, okay? But take a look at the highlighted questions. Is there a time where this will happen? Okay? Does the table, data in the table support the conclusion that this will happen? So here it doesn't say, is there a time where this exists? It already tells you that it exists. It's just explain why this must happen. Is there a time when something happens? Is there a number C such that something happens? Explain why there must be at least one moment where something happens. So justify why there must be at least one time t. So you kind of get the idea of how they're going to ask this. Must there be a value of x at which? Is there a time t? Is there a time t? And explain why there must be. Okay, so you can kind of see the similarities in the phrasing of it. So here's how you actually handle it. So by the end of this video, I'm very confident that you'll get this down. Okay, here we go. Here's the first problem. First thing you want to do is, now that we've identified that this is an IVT or MVT problem, okay, here's what you do. What are they asking for and what do they give you? They give you C of t, and they're asking for the derivative, okay? Now, if they ask for just C of t again, then you would be using IVT. But since they're asking for the derivative of what they gave you, we're going to look for MVT here. Okay? So here we go. MVT, you need to know if it's continuous on a closed interval and differentiable. So first, you want to make sure that you have this covered first, okay? Very sneaky. They tell you that it's a differentiable function from 0 to 6. So remember, if D, then C. So these two conditions are satisfied, okay? So we're allowed to use MVT, but it doesn't mean that it'll work yet, okay? So now what you have to do is from 2 to 4, you have to get a slope of 2. So you have to show that the average rate of change comes out to 2. Now in this case, you pick 2 points. Now usually it's the endpoints. So at 2 it's 8.8 and at 4 it's 12.8. All right. And if I find the average rate of change, it'll be 12.8 minus 8.8 all over 4 minus 2. That comes out to 4 at the top, 2 at the bottom. This comes out to 2 there. So that's the average rate of change. What you guys found out here is, and you don't have to draw this one out. This is so that you understand it. Okay? That is your average rate of change. Okay? So that guarantees somewhere in between 2 and 4 where that tangent will have a slope of 2 as well. Okay? That's just to get you to understand it. Okay, so here we go. This is what you would be showing on paper. I'll erase everything that's not necessary here. Okay? So then I would say, therefore, by MVT, there is a time t in the interval 2 to 4 such that C prime of t equals 2. All right? Okay. I'm going to find another, actually, let's just move on. Okay? Here's part B. So again, we want to see what they're asking for. They're asking for the velocity of train A. They're asking if it's possible for it to be negative 100. So this is what they're asking for. And this is what they're giving you. If you notice, what they're asking for and what they're giving you is exactly the same. So if it's exactly the same, you're going to lean towards IVT. Okay? So IVT, you got to make sure that it's continuous. Okay, is it continuous? How do we know that? We know it right here. It's differentiable. Okay, so again, if D, then C. Okay, so we know it's continuous. Okay, so is there a time from 5 to 8, somewhere in between, where the velocity will be negative 100? Okay, so first you have to see if it's possible. So if you start at 40 and you end at negative 120, will you eventually cross negative 100? Yes, so you would. So therefore, by IVT, there exists a time t in 5 to 8 such that VA of t equals negative 100. And that's it. Okay? All right, let's keep going. Okay, so what we're going to do here now is we're going to identify if it's IVT or MVT. Okay, and then we'll actually work out the problems at the very end. So here we go. Now here, they're asking for F double prime of C equals 0. It's kind of tough to see what they give you here, but at the very most, they give you F and F prime. So that's at most what's given, and they're asking for the second derivative. So right away, I'm thinking that MVT works best because I have no information about F double prime. they're asking for the derivative of what they gave me, okay? So MVT is best here. I'll come back to it. Here, they gave me R of t, okay? Okay, so R of t, and they're asking you, is there a time when the rate at which the water is being pumped the same as the rate of water is being removed? Okay, so here again, you're going to use some version of IVT because the rate at which water is being pumped is R of t. Okay, so what they give you and what they're asking for is the same thing. Now, how you solve this one is a little bit different, but I'll come back to that later. Here's the next one. Is there such a thing where G prime of C, so they're asking for G prime of C, and what they give us. So here, this one is a little bit tricky, but take a look. They give us G, but they also give us G prime. So if they give us G and they ask for G prime, I could consider IVT, but since they gave us G prime as well and they're asking for G prime, either one could come into play here. So this is one of the trickier ones, but we'll come back to that as well. Here, they're asking for H prime of t, and here they give you H. Okay, so because they're asking for the derivative of what they give us, sorry, not IVT, whoops, MVT would be best here, okay? And again, I know I'm moving a little bit fast, but you could always pause and replay if you need to, okay? Here they give us velocity, V sub P of t, and they're asking for the derivative, okay? So right away, I know it's going to be MVT. Here is the only time where they're talking about absolute max. So this is a rare case, I'll go over anyways, where EVT would come into play. Okay, here we go. So is there a time t at which Brandon's acceleration is equal to 2.5 miles per hour? So this acceleration, you have to understand that since this is miles per hour, that is the velocity. So what they gave you was B of t. What they're really asking for is B prime of t, acceleration. So here I would use MVT. Is there a time t where Brandon's velocity is equal to Chloe's velocity? Now here, I mean, since they're talking about velocity, I would initially say it's IVT, but there could be a different way of solving that, and I'll get to that. 2013, they give us W prime. They're asking for W prime. Right away, I'm thinking IVT. Hopefully that gave you a little bit more clarity in terms of solving it, okay? I'll go over a couple of IVTs and a couple of MVTs. I don't think I have enough time to do all of it. Plus, also, you guys have already had these videos, okay? So let me just pinpoint a couple here. All right, so let's do a couple of MVTs. So here, MVT, remember, you have to know that it's continuous and differentiable. Right away, we know that that's going to be true because of this statement here. Okay, it's twice differentiable, so it's going to be twice continuous. But that's not enough to say that, yes, it exists. We know that we can use MVT, but we have to show somewhere between -1 and 1 that the average rate of change comes out to 0. So take a look. I'll highlight it. At -1, the derivative is 0, and at 1, the derivative is 0. So here are my 2 points, -1 comma 0 and 1 comma 0. If I find the slope here, or the average rate of change, it's going to be 0 minus 0 over 1 minus -1, which is 0 over 2, which is 0. Therefore, by MVT, there exists a C somewhere between -1 and 1 such that F double prime of C equals 0. You'll start to notice that the structure of the statements are going to be very, very similar. Okay, let's keep going. Let's go to MVT. Okay, here, 2018. Okay, so checklist again. Is it continuous? And is it differentiable? Okay, we know that that is true. So check and check. Okay, so here we go. We're going to find the average rate of change. Okay, somewhere between 2 and 10. Okay, now usually you try to use the endpoints first. Let's try to use 2 and 1.5 and then 10 and 15. Let's find the average rate of change here. That's going to be, 13.5 over 8, which is definitely not coming out to 2. We want to aim for 2 here, okay? So you're trying to pick 2 points. So notice how here it's not always just the endpoints. You're trying to pick 2 points that come out to 2 as a slope. And again, you're testing it. I noticed, just because I've done this long enough, but I noticed that when I have 3, 2, and 5, 6, in my head, 6 minus the 2 will give me a 4, 5 minus the 3 will give me a 2, 4 divided by 2 will give me a 2. That's just with a lot of practice, okay? But you can do it too with time. So because we know it comes out to 2, the average rate of change, therefore, by MVT, there exists a t somewhere in 2 comma 10 such that h prime of t equals 2. Okay, I'm not going to write everything down. Let's do one more. Okay, here. Justify why there must be. So we already know that it's going to be true. So one, do we know that it's continuous? And do we know that it's differentiable? I should say continuous on a closed interval and differentiable on an open interval, okay? But there you go. We know it's differentiable, so it's also going to be continuous. And we want to show where the derivative comes out to 0 here. So we need to find 2 points where the slope will come out to 0. This one's a little bit easier to spot. It happens to be the endpoints, but also I noticed that when you have the same y values, your slope is going to come out to 0. So 55 minus 55 over 2.8 minus 0.3 eventually comes out to 0. Therefore, by MVT, there exists a time somewhere between 0.3 and 2.8 such that A sub p of t equals 0 or V sub p prime of t equals 0. Okay? Okay, I think that's enough for MVT. Let's do some IVTs. I'm going to move on. Now that I'm looking at this, I want you guys to stick with the pattern. It is IVT here, but I'll talk about that. Actually, you could just watch the video there, okay? Okay, now here's one that's tricky because they give you G and G prime, and they're asking for G prime. So really, IVT or MVT comes into play. And this is the rare case where you actually have to check both, okay? So initially, what people do is they lean towards IVT, okay? So from -5 to -3. So let me highlight it. From -5 all the way to -3. Okay. Based on these values, will you ever reach -4? Are you guaranteed to? When you're traveling from -3 to -1, you're not guaranteed to hit -4. And from -1 to 4, you're not guaranteed to hit -4. So right away, by that observation, I know that IVT, the theorem will work, but based on what they gave us, it's not guaranteed that you'll eventually hit -4. So you can't use IVT there. But that doesn't mean that there doesn't exist a number C, because we still have to check for MVT. Now, again, we have to check to see if it's continuous and differentiable, and it indeed is. Okay. Okay, so here we go. Here we go. Sorry, brain fart. Okay, so we want to see if it's continuous and differentiable, and it is. But then now we have to check for the average rate of change. So from -5 to -3, let's take a look at my points here. -5, -3, -3, comma 4. Okay. 4 minus -3 all over -3 minus -5. That comes out to 7 over +2. Okay, that doesn't work. So let me try another 2 set of points. Let's try, oh, I'm sorry, MVT. So we actually have to use the G, sorry. So -5, 10, -3, 2, 2 minus 10 all over -3 minus -5, that's -8 over +2, which is -4, which is exactly what we want. So therefore, by MVT, yada, 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 yada. Okay. EVT here, EVT will work as long as it's continuous. So whenever you have a piecewise function, we know that this is continuous and this is continuous. But the only thing that's in question is it continuous at where it breaks? So you actually have to show continuity here at x equals 0, which is a little bit of work. But then after that, once you prove it, then you could say by EVT, since the function is continuous, yada, 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 yada. Okay? Okay. I think that's enough. Okay, you guys can go through it, but again, still text me if you guys have any questions, or if you want to meet, we could talk about this more. But I think I've given you guys enough clarity there. If you do watch the video, please do give me a quick response on Remind. Let me know if it makes a lot more sense or if it doesn't. Okay, thanks.